Hi guys, this is the notes for Chapter 9 for Advanced Chemistry. They're on hybridization. Here are some resources that you will need. I put a PDF of these resources on Google Classroom for you as well. You can use those on your quizzes and assignments that you do. Okay, so hybridization has to do with what type of orbitals electrons are in when they form bonds. We have learned electron configuration, but what we've learned so far is the really basics of it. So this bar represents energy, and as that energy increases, you can see electrons will be in the 1s or the 2s, 2p, 3s, 3p, and goes all the way up. But those are the orbitals that we've learned that they will be in. And you learn to write electron configurations. However, that's all fine until you start to look at the electrons of atoms that are involved in bonds. And what we see then is that this is too simplistic and we need to learn something just a little more complex. So, for example, if we started out by looking at a Lewis structure for methane, we'd have carbon with 4 single bonds to hydrogen in that Lewis structure. Each of these bonds represents 2 electrons. Okay, now one of those belongs to hydrogen. And since hydrogen is, its electrons are in the 1s subshell, it only has that 1 electron. So this is going to be a 1s electron. This one as well would be a 1s electron. And the same with each of these. So this electron is a 1s electron and this electron is a 1s electron. Okay, now let's look at these electrons in carbon. So carbon has 6 electrons. It has 1, 2, 3, 4, 5, 6. Okay, now 2 of those electrons would be in the first shell, so those are not represented right now because it only bonds with its valence electrons. So these are its valence electrons. 2 2s's and 2 2p's. So this one might be a 2s, and this one a 2s, and this one would be a 2p and a 2p. Okay, but there's a problem because the bonds between different kinds of electrons, like this one is a 2s and this one is a 2p, the bonds between different kinds of electrons are different lengths. And it is known by experimentation that the bonds between the carbon and the hydrogen in methane are the same length. So what that means is that this, what I've just drawn for you, is not the way that this would actually happen. Okay, so we determined this is what doesn't happen, so we need to look now at what actually does happen. So carbon has these 4 electrons, and right now they're in different orbitals, and so that isn't going to be what's going to happen, so we need to get them into the same orbital. What actually happens is one of these electrons that's in the 2s orbital will become promoted to the 2p orbital. And so now we have 4 different electrons, each still in different orbitals, but what they do is they form a separate, what is called hybridized orbital. And this orbital is an s, this is a p, this is a p, this is a p, and there's 1 electron in each of those orbitals, and so each of these electrons has the same amount of energy, because it comes all from the same hybridized orbital. And so instead of these electrons being different from each other, they're all the same. And the way they name these hybridized orbitals is by how many s and p orbitals there are. So in this case, there's 1 s and 3 p orbitals. So this is called sp3 hybridization. In an sp3 hybridized orbital, there's 1 orbital that's an s and 3 orbitals that are p. Each of them has the same amount of energy, which is what causes the bonds to be the same length. So if we have sp3 hybridization, like we just talked about, there's going to be 1 s orbital, which is a circle. And then there's also going to be 3 p orbitals, and the p orbitals had this type of shape. And so what's going to happen is you're going to end up with an orbital that looks a lot more like the p orbital, because there's 3 of those. It's 75% p character and 25% s character. And so it's going to end up having a big lobe like the P, and then the smaller lobe. So this is the P character and this is the S character, but this is what the shape of the orbital would look like. And what you're going to see in pictures is there's going to be these lobes coming off. Those are the bigger parts of the lobes, and you have to count how many there are to see how many different orbitals there are. So if this was the picture, there would be 4 orbitals. Well, that would be 1s and then P3. And if we had a picture where there were only 2 lobes coming off, that would just be SP, because there's 1s and 1p orbital shown here. So here are all the different options. We're going to talk about the number of lobes that you're going to see on a picture, and then we're going to figure out what kind of hybridization it's going to have. And this information is going to be on the chart. If it has 2 lobes, which is the smallest amount, the hybridization, it has 2 orbitals, so it goes S and then P. If it has 3 lobes, there's going to be an S orbital and then 2 P orbitals. If it has 4 lobes, there's going to be an S orbital, 3 P orbitals, and then if it has 5 lobes, we're going to have an S lobe, 3 P lobes, and that's all that there are for P. The 2P subshell has 3 different orbitals. So the next one after P is going to be D. So if there's 5 lobes, the hybridization is going to be S, P3, D. That represents the 5 different orbitals that would be in that subshell. And then we have 6, and that one is going to be S, P3, D, 2. Okay, so here's the first kind of problem that you're going to need to do. And the first thing you're going to do is look at the picture and see how many lobes there are. So this one has 1, 2, 3, 4, 5, 6 different lobes. So we need, for 6 different lobes, there's going to be 1 S. There can only ever be 1 S. The P is going to have 3, 4. That gets us to 4. So then we need 2 D orbitals. So sp3d2, it's tricky. It says if no picture matches, choose not shown. So we'll look and see which one we need to put that for. Okay, so B has 1, 2, 3, 4 lobes. So we need an S, 3 P's to give us the 4 lobes. And then this one has 1, 2, 3 lobes. So we need SP2. So SP2 is going to be picture C. SP3 is going to be picture B. And here we're going to put not shown. For this part where it says electron pair geometry, we are going to be trying to find out the basic shape of this. And what we're going to have to do is go to our resource sheet. So we are looking for SP3D hybridization. The one that says SP3D down here goes along with the trigonal bipyramidal electron pair geometry. So in here we would want to put trigonal bipyramidal. SP3, and it goes with tetrahedral. SP2, same thing, we would look at our resource sheet, trigonal planar.